Good morning all. Maxwell's speed distribution law. Assumptions of him are: gas consists of molecules with all possible speeds between 0 and infinity. Means gas molecules will have all possible speeds between 0 and infinity. The second thing, if the gas is in equilibrium state, then average distance of molecules in a vessel in equilibrium is same at all places. Now here, though the speed of individual molecules are changing, but a definite number of molecules will have definite speed between definite ranges. The probability of any molecule selected at random has velocities lying between certain limits, which is purely function of velocity, and the limits considered. And lastly, the components of velocity of molecules are mutually perpendicular to each other and are independent of each other. Now let us derive the expression for Maxwell's speed distribution law. Right? So now we are deriving the expression for Maxwell's distribution law. Now for this, a three-dimensional coordinate system x, y, z, a container I considered. In that, at point P, let us consider a molecule, right? Let the resultant, that velocity of that molecule be c. Okay, now let us resolve this c into three components, velocity components, u comma v comma w. Okay, so we are resolving into three components. One is velocity of gas molecules along x direction u, along y direction v, along z direction w. Let the length of this container along x direction du, along y direction dv, along z direction dw. Alright. Now the probability of given molecule, the probability of given molecule have its velocity lying between u and u plus du range is written as function of u and du. Means how we will write? F of u du, right? Similarly, the probability of given molecule having its velocity lying between the range v and v plus dv is written as function of v and dv. Similarly, the probability of given molecule having its velocity lying between w and w plus dw is written as function of w and dw, f of w dw, right? Now the probability that molecule having its velocity between u and u plus du, v and v plus dv, w and w plus dw can be written as f of u f of v, f of w, du, dv, dw. We multiplied these three. The probability of molecule having its velocity between these three ranges is written as f of u, f of v, f of w, du, dv, dw. Now we said the resultant velocity of molecule is c, right? Now this c can be written as the function of the c and du, dv, dw, that is f of c, du, dv, dw. Or we can also write it as molecule is in sphere shape. Molecule as it is in sphere shape, we can also write it as pi c square du, dv, dw. Already we know the sphere equation, no? R square equal to x square plus y square plus z square. In a similar manner, c square will be equal to u square plus v square plus w square. Alright. So now here resultant velocity is nothing but equivalent to f of u, f of v, f of w, du, dv, dw is nothing but equivalent to the resultant velocity pi c square du, dv, dw. This strikes off, we get f of u, f of v, f of w equal to pi c square, right? Now next, here c square equal to u square plus v square plus w square defines sphere with radius c. Sphere with a radius c. Now let us differentiate the above equation. D of f of u, f of v, f of w is equal to d of pi c square. Now for our convenience, we are taking pi c square as constant. So d of f of u, f of v, f of w is equal to 0. Now differentiating this, we get f dash u, f of v, f of w du plus f of u, f dash v, f of w dv plus f of u, f of v, f dash w dw is equal to 0. Right? We differentiated that. Okay. And now next, divide the whole equation with f of u, f of v, f of w. What we will get? F dash u, f of v, f of w du plus f of u, f dash v, f of w dv plus f of u, f of v, f dash w dw by f of u, f of v, f of w equal to 0. Separating it, f dash u, f of v, f of w du by f of u, f of v, f of w plus f of u, f dash v, f of w dv by f of u, f of v, f of w plus f of u, f of v, f dash w by dw. F of v, f of u, f of w is equal to 0. Here f of v, f w, f of v, f of w, f of u, f of u, f of w, f of w, f of u, f of v, f of u, f of v strikes off. So what is remained? Now one second. F dash u by f of u du plus f dash v by f of v dv plus f dash w by f of w dw is equal to 0. Put it as equation 1. Correct? Now let us differentiate c square equal to u square plus v square w plus w square. C square 0. So 2u du plus 2v dv plus 2w dw is equal to c is constant, no? 0. So u du 2 cos as common, v dv plus w dw equal to 0. Now multiply this with lambda, a constant. Lambda u du plus lambda v dv plus lambda w dw is equal to 0. Let it be equation 2. Now let us add 1 and 2. I am adding u with u, v with v, d with w with w. We get f dash u by f of u du plus lambda u du plus f dash v by f of v dv plus lambda v dv plus f dash w by f of w dw plus lambda w dw is equal to 0. As u comma v comma w are independent of each other, we can equate them separately to 0, such as f dash u by f of u du plus lambda u du is equal to 0. F dash v by f of v dv plus lambda v dv is equal to 0. Similarly, f dash w by f of w dw plus lambda w dw is equal to 0. Now let us take this f dash u by f of u du plus lambda du equal to 0. So it implies f dash u by f of u du is equal to minus lambda u du. Now let us integrate this. Integration of f dash u by f of u du equal to minus lambda integration of u du. Integration value of this is log e f of u equal to minus lambda u square by 2 plus log ea, where log ea is integration constant, right? And now log e f of u minus log ea is equal to lambda u square by 2. We know that log ea minus log eb means we will write it as log a by b. Using this formula, we will write log e f of u by a is equal to minus lambda by 2 u square. Now, or we can also write f of u by a is equal to e to the power of minus lambda u square by 2. Now put lambda by 2 with another constant b. So f of u becomes, we are sending a to this side, a e to the power of minus, instead of lambda by 2 I am substituting b, and as usual u square. Similarly, we can write f of v as a e to the power of minus b v square. F of w as a e to the power of minus b w square, right? We can write in such a way. Now next, so what we got? F of u f of v f of w. What we got? A e to the power of minus b square, a e to the power of minus bv square, a e to the power of minus bw square, that is equal to a cube, a into a e to the power of minus b, if we take common, u square plus v square plus w square, right? Now integrating above equation between limits minus infinity to plus infinity, we get the constant values AB. Now according to the definition of probability, integration of minus infinity to plus infinity, f of u, f of v, f of w, du, dv, dw is equal to 1. Now what is the value of f of u, f of v, f of w? Let us substitute. Minus infinity to plus infinity, a cube e to the power of minus b u square plus v square plus w square. Now as it is, you write du, dv, dw is equal to 1. Alright. Now we know that integration of minus infinity to plus infinity e to the power of minus b u square du value is under root pi by b. Similarly, this is for also integration e to the power of minus b v square du is also the same value. So integration minus infinity to plus infinity, a cube, sorry, we are substituting, no, a cube. Now integration of e to the power of minus b u square is under root pi by b. Similarly, integration of e to the power of minus b v square is also under root pi by b, and last one is also under root pi by b equal to 1. So a cube, it becomes pi by b whole to the power of 3 by 2, that is equal to 1. Now it becomes a equal to b by pi whole to the power of 1 by 2. Right. Now next, but from kinetic theory, the value of b is m by 2 kt. Now if we substitute, a becomes m by, here pi is there, 2 pi kt under root. Right. And now the number of molecules, dn having velocity components lying between u and u plus du, v and v plus dv, and w and w plus dw is written as dn equal to n, number of molecules, a cube e to the power of minus b u square plus v square plus w square du, dv, dw, that is equal to n. Now what is the value of a? Just substitute m by 2 pi kt, 3 by 2 it becomes a cube, no, 3, and this is 1 by 2, so it becomes 3 by 2 e to the power of, what is the value of b? Minus m by 2 kt u square plus v square plus w square du, dv, dw. Alright. And now this we call it as Maxwell's distribution law. Right. And now for the further derivation, to find out the speed distribution law in terms of velocity, in terms of velocities, let us consider that total number of molecules lies between the speed range c and c plus dc. And now if we consider two concentric spheres with the radii of c and c plus dc, then the volume becomes, for sphere volume is 4 by 3 pi r cube. We are following that only. One sphere is having the volume 4 by 3 pi c plus dc as radius whole cube. Other sphere is having 4 by 3 pi c cube, that is 4 by 3 pi c plus dc whole cube minus c cube. On simplification we get 4 pi c square dc as volume, right? Volume of the element. Now next, and now let us substitute this 4 pi c square dc for du dv dw and c square for u square plus v square plus w square. What is dn value? Dn value is n m by 2 pi kt 3 by 2 e to the power of minus m by 2 kt u square plus v square plus w square into du dv dw. Now this becomes n m by 2 pi kt whole to the power of 3 by 2 e to the power of minus, in this place I am saying to substitute c square by 2 kt and in place of du dv dw 4 pi c square dc. Now just writing in a systematic manner, dnc by c dnc by this n I am writing this side is equal to, I am writing 4 pi in front. Now next, m by 2 pi kt whole to the power of 3 by 2 e to the power of minus mc square by 2 kt c square dc. Now this is the Maxwell's law of distribution of molecular speeds in a gas. This is Maxwell's distribution law for molecular speeds in a gas, right? Now first we find out the Maxwell distribution law, that is n m by 2 pi kt whole to the power of 3 by 2 e to the power of minus m by 2 kt u square plus v square plus w square du dv dw. Now in place of du dv dw we are substituting 4 pi c square dc. In place of u square plus v square plus w square we substituted c. So we got Maxwell's law of distribution of molecular speeds in gas as dnc by n is equal to 4 pi m by 2 pi kt whole to the power of 3 by 2 e to the power of minus mc square by 2 kt c square dc.